All right, so today's class we are going to continue with density. Last class we had looked at our density formula, which is mass over volume. So we had done a couple examples on how we can calculate the density of a substance, knowing its mass and knowing its volume. When we look at solids, the density is in grams per centimeters cubed. When we are looking at liquids or gases, our density is in grams per liter or grams per milliliter. So today we're going to look at the other two formulas that we can get from our density formula. Is you may be given density and volume, and you have to solve for mass. So using this triangle, you can cover up mass, and you're left with density times volume. If we're trying to solve for volume, so again on our triangle we just cover up volume and we have mass divided by density. So mass divided by density to calculate for volume. All right, so we had worked on these examples already. So we were going to calculate for volume. So this question states that a block of aluminum has a mass of 5.40 grams. What is the volume of the aluminum? So we're going to use our table to get some more information about aluminum. So aluminum is right here, and from here we can see that aluminum has a density of 2.70 grams per centimeters cubed. So now we have the mass and we have our density. So I'm just going to note that down here. We know our mass is 5.40 grams, and we have our density, which is 2.70 grams per centimeters cubed. And we need to solve for volume. So volume is what we need to solve for. So our formula for volume is take our mass and we're going to divide it by the density. So I've done it here, but I'm just going to lay it out so it makes more sense here. So our mass was 5.40 grams, and we're going to divide it by our density, which is 2.70 grams per centimeters cubed. All right, so next you would just put that into your calculator. 5.40 divided by 2.70, and we will get our answer of 2.0 centimeters cubed. So that is the volume of aluminum. Okay, so our next example here, calculate the mass of a substance that has a volume of 5.0 centimeters cubed and a density of 8.92 grams per centimeters cubed, and then use table 1.5, which is here, to determine what substance this is. All right, so calculate the mass. That's what we don't know. So I'm just going to do it up here. Mass is what we don't know. Mass is in grams. We do know our volume. Our volume is 5.0 centimeters cubed. Because it's in centimeters cubed, we know this will be a solid. And we also know our density. So from our question, so here's the volume was given to us, and here's density that's given to us, 8.92 grams per centimeters cubed. Okay, so our formula for calculating mass is density times volume, okay, which is done here, but I'm just going to do it again. So mass will be density, which is 8.92 grams per centimeters cubed, and we're going to multiply that by 5.0 centimeters cubed, which is our volume. All right, so you would put this into your calculator to calculate your mass, and we get our mass of 44.6 grams. All right, so that is the mass. The next part it tells us is determine what substance it is. So this is a density table, so we would have to use this density that was given to us, 8.92 grams per centimeters cubed. So you're going to go down there to find it, And here it is, 8.92 grams per centimeters cubed, so therefore the substance is copper.
Just like all matter, water has physical properties that can be measured and calculated. To find the mass of water, you need a beaker and a scale. First, find the mass of the empty beaker. Then, fill the beaker up with your desired amount of water. Next, use the scale to find the mass of the filled beaker. To find the mass of just the water, we need to subtract the mass of the empty beaker from the full beaker. Our sample is 100 grams. The volume of water can be measured using a graduated cylinder. Our sample is 100 milliliters. Density is calculated by dividing the mass by the volume. Plug in your measured mass. We measured ours to be 100 grams. Divide that by the measured volume. Our volume was 100 milliliters. Water's density is 1 gram per milliliter. Objects with a density greater than 1 will sink when placed in water. Objects with a density of less than 1 will float when placed in water. If a block has a density of 0.1, it will float because its density is less than 1. Another block with a density of 0.5 will also float because its density is less than 1. Notice that more of the block was below the waterline. Another block with a density of 0.9 is also less dense than water, so it will float. We can see that as density increases, more of the block is below the waterline. Scientists have discovered that the block's density tells us exactly where the block will come to rest. If the density is 0.1, then 10% will be below the waterline. To calculate where a block will come to rest, just convert density to a percent. Density also explains why ice floats. If you freeze water, it expands. Let's use the black dots to represent the atoms in water. When you freeze water, no new atoms are added to the water. So because of the expansion, there is more room between the atoms. Compared to the atoms in liquid water, the atoms in the ice are not as tightly packed together, causing the ice to float. So try calculating density for yourself. It's mass divided by volume.
Are you ready for a brain teaser? What weighs more, a pound of feathers or a pound of bricks? Well, they weigh the same. It's a pound of each. The mass is the same, 1 pound. If you got that wrong, you might have actually been thinking about density. There would have to be a lot more feathers than bricks to equal 1 pound, but that's not what the question was asking. So if you thought brick was the right answer, you're probably thinking of density, not mass. Density takes both mass and volume into account, which will tell you something about the compactness of the atoms. To calculate density, we use mass over volume. Now, I remember this because it looks like the DMV, and I just love going to the DMV, except not really. But it's a way to remember it. Now, density is an intensive property, which means as long as you have the same substance, it will have the same density, no matter how much of the substance you have. It depends only on the composition of the substance, not the size of the sample. So you could have a small gold coin or a large, heavy gold bar. Both the coin and the bar would have the same density, 19.3 grams per cubic centimeter. Density is often measured as grams per cubic centimeter or grams per liter. 1 gram per cubic centimeter is the same as 1,000 grams per liter. Since solids and liquids have higher densities, we tend to use grams per cubic centimeter, but for gases with their low densities, we tend to use grams per liter. It's important for me to note that as temperature rises, volume increases. which makes the overall density decrease. Generally, density decreases as its temperature increases, with a few exceptions to the rule, of course. The most important exception is water. Water is actually at its most dense in the liquid phase at about 4 degrees Celsius. When water freezes, it forms a crystalline pattern that leaves more space between the molecules, increasing its volume and lowering its density. This is why ice floats on water. It's actually less dense. But you can change the density of a substance like water. Adding a solute to a substance will change its density. If you add a high-density solute like salt, whose density is twice that of water, you'll end up with a solution that has a higher density than water. This is why it's so easy to float in salty water, like Salt Lake or the Dead Sea. The opposite is true too. Adding a low-density solute will lower the density of the solution. Ethyl alcohol has a density that's lower than water. When you mix alcohol with water together, the overall density is less than the water's density alone. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.